Hi everyone, it's wonderful to connect with you and talk about data mesh, a paradigm shift in analytical data management. I'm sure you're all excited, hopefully you're excited to hear about what it is and how we can build it. But I think it's important for us to start with the story of it, as why it came to exist. I love this quote from Joseph Campbell, who was an American professor of literature, and he influenced, in fact, the work of George Lucas on Star Wars, that he said, everything starts with a story. So what was the story of the data mesh? I think similar to Star Wars, if there are any fans out there, Star Wars always starts with with a big scene, with a big battle, crisis, and really data mesh came from a sheer frustration and a lot of crisis. About 2018, we saw a huge demand from our progressive clients, and progressive in terms of big data management and technology and architecture, clients that have been investing millions of dollars. They have built their first generation, second generation data platforms, and they were struggling with their, with getting value out of data. And they were asking us to give them an alternative point of view. And that was the point that I became quite curious about what has been going on in the big data space. I came from distributed systems, from microservices world, from operational world. So I kind of understood how we scaled out operation in that world. So we started looking into the big data architecture, and to my surprise, it felt like we had fallen behind in adopting kind of modern architecture or system architecture in that space. And we started doing research even further to look at what the industry landscape looked like. And I put some numbers from now a slightly outdated, I suppose, New Vantage Partners release report, which is a report from executives around the world. And what these reports showed, that while we were accelerating investing in AI and big data, and there's a huge acceleration in both amount and the pace of innovation, pace of, investment, all of these executives were losing confidence in actually getting results. And when they were asked to measure themselves on transformational metrics, metrics that really matters to change an organization to become data-driven, to treating data as an asset, we talk about it all the time, and really competing on data analytics, they unanimously measured themselves as failed. So that was the moment of crisis, that things just didn't make sense, and we needed to think out of the box and come up and learn from what we had learned over the last decade or so from the operational systems and microservices, and bring that to the world of data. So let's begin looking at the existing paradigms, right? The past paradigms. Everything starts often with these two big separation between operational data plane and analytical data plane. Operational data is basically constitutes of databases that runs our microservices, runs our applications. They run the business effectively. There are the databases that sit behind some sort of API, and they keep the current state, right? So if you have a customer, let's say microservice or service, and you want to register a customer, you have an API call, and beneath that API sits this database that transactionally now, adds a new customer. Or if you want to change the address of this customer, you call an API, and underneath it, there's a database that keeps the current state of the customer and changes the address. And, for a while, we have had a great evolution around, databases, operational data. Of course, there's still room for improvement around elasticity and so on, but that's the world of operational data. Very separate from that world exists this analytical data or big data that came traditionally from BI and reporting. People still refer to it as reporting. It's no longer reporting, right? Because AI and ML require a different view of the data. And that is, in fact, data that shows the changes and historical view of the state changes as they happen. It's an aggregation of all of the data across across our organizations, within and beyond the bounds of organizations. And they give you this historical view and kind of the aggregated view of all of the changes that have happened. And you can, as a data scientist, train your models looking at data, or as a data analyst, run some reports to show the trends of your business, for example. And for a really, really long time, that means decades, I guess in my lifetime, decades, we have been using this idea of running an ETL, extract, transform, load job between this one plane to another plane and have separate teams to take care of that. And I think that's one of the root causes of the situation that these organizations were finding themselves. So to give you a very quick rundown of the history of how we have architected this analytical data world, we have had data warehouse, which essentially been extracting data out of these operational databases and putting them in, model them perfectly, kind of putting them in a straitjacket of, perfectly modeled star schema so that we can run reports over them. And I sprinkled on this slide a few technologies that, we've been using in this space, Power BI, BigQuery, Looker, and so on, to allow to create this relational entity relationship view or tabular view of the world at large so that we can run SQL queries. And then, around 2010, we found ourselves in a position that this process, this approach to architecting analytical data is not really working for the needs of today because it requires this modeling extraction and then this modeling and transformation piece in the middle, and that takes a lot of time, and data scientists and machine learning actually don't need a perfectly modeled data. So why don't we invert this slightly, and then we introduced the concept of data lake, which still gets data extracts data from all of these operational services, and now puts it in a semi-structured or unstructured kind of blob storage that, we can unleash the data scientists to go find the signal out of the noise. And then if we find, valuable kind of modeling of the data for fit for purpose use cases, we bring them to the edge of the lake. We call them lakeshore mods. And then I add there, a few set of examples of technologies that allow these transformations and pipelines to be built, allow blob storage to be kind of used for distributed files and so on. And when we found ourselves kind of constrained with the cost and, the challenges of implementing even data lake, now we have the next generation, which is build the data lake, but build it on the cloud. And this is just an example of a sample, kind of enterprise architecture, solution architecture that you find on cloud providers that advertising the lake architecture. And it's the same story. Get data from one end of the organization, put it in one giant place, and then model it downstream from there. And if you look at the underlying characteristics that are shared between these models, one very obvious one that was very obvious to me because I had moved on from centralized kind of planning or architecture is that this is a very centralized and monolithic approach to managing data, that it expects that there is one system. Of course, the system is broken down in multiple parts, but yet nevertheless, one big lake that we need to hydrate, from all of these kind of operational systems, and then one system to satisfy the needs of the organization across the domains, across the various, use cases that they have. And like any other centralized or monolithic approach, this process, this architecture has a lot of constraints. It does not scale. It's a constraint for scaling your operation. I think it's important for us to talk about people when we talk about architecture. Architecture and organizations are tightly coupled. How we build our systems, how we demarcate, boundaries of system is essentially mirrors how we group folks. So what we find out with that architecture, that there is a centralized now data team, very independent and separate from domains where the data generated or domains data gets used, that now is responsible for making sense of data from all of these wonderful places that the data comes from, make sense of it, cleanse it, transform it. And you hear these words, these languages of the language of the past paradigm: ingest, cleanse, transform, so that's their job. But if you look at their everyday life, actually, I have a lot of empathy for these folks because they've been put together because of their technical skills, not so much understanding of the domain, and they have to make sense of data from people or systems that have no incentive of really giving them data that is understandable or cleansed or has quality. And then to resolve some of these scale problems, and a scale I don't mean in terms of like petabytes of data, but a scale in terms of decomposition of the function of the system, so we can now decouple teams and parallelize activities and progress. then the approach around the data lake or data warehouse has been around the pipelines. You hear, again, another word that you hear a lot in the past paradigm, pipelines. So they have the groups, trying to optimize the ingestion part of these pipelines, and you have groups that try to optimize transformation and serving. But the reality is that the change happens orthogonal to this decomposition of the architecture or decomposition of the group. If you need to add a new source of data, and if you need to have a new use case, often these changes are crossing all of these boundaries, and all that means is, challenge with scale. Execution has been very disconnected and very difficult as well. Where do you start with a centralized big bang kind of implementation? Do you start from the source? Do you start from the consumer? Do you start in the middle? We've seen a lot of disconnected kind of execution. So I think that moment of crisis that led us to start challenging the status quo is very much clear in this picture, that for decades we've been trying to solve the problem of analytical data with centralized solution, hyper-specialized siloed group of people, and disconnected execution. And if you have any of these failure symptoms on this slide, it might have something to do with the architecture that you have deployed. And a lot of our clients have this kind of scale problems, the scaling more, getting more data, or scaling, getting more consumer use cases satisfied. So where do we go from here? Let's look at the kind of the 50,000 foot view of the architecture. How about breaking the architecture apart into smaller pieces around the domains, right? So this is an approach, domain-driven design, or decoupling both organizational structure as well as architectural structure around the bounded context of business domain, is something that we have adopted and we found helpful and useful to scale in operational world. So what does that look like in the big data world? Well, if we already have decoupled, which a lot of organizations have already done that, decoupled our organization based on the bounded context of the business domains. For example, in an e-commerce, you will have, your e-commerce team, order management team, customer management team. So these are the functions of the business that you already have, royalties and credit cards and things like that. So each of those boundaries already have their operational systems that are satisfying, or microservices that are satisfying the needs of the business. What if we say that, that big data, analytical data that we talked about on the first kind of page, let's give the accountability and responsibility of serving that analytical data to these domains, to the domains and people that are most familiar with the data and are in a position to actually provide that data. So that's the first principle of the data mesh, is the composition of both architecture as well as accountability and ownership of the data to the domains. And then domains might have different alignments, might have an alignment with the source, or alignment with the consumption, or a new aggregate domain that we might create. The second principle of the data mesh is that, well, if we do now, decompose this data ownership, how can we avoid this problem of silos of the data? How can we avoid now finding data across this distributed kind of model of ownership? And the answer to that is, well, we need to think about data as a product with people who are accountable for that product, as in their KPIs are associated with how satisfied the customers of their data are, how much friction you've removed from their processes, and what's, the lead time to consumption of that, and really delight the experience of data users. And the data users are, data scientists, data analysts, people that write reports or applications that consume analytical data. So serving data as a product and assigning people with accountability and responsibility to do that is the second pillar of data mesh. I've listed a set of attributes that I think are important and are meaningful to thinking about data as a product. I love this book by Don Norman. If you haven't read it, you should read it. It's a classic. Design of Everyday Things. And when he talks about designing objects, he has a few characteristics, a few underpinning principles that every good object, everything that you design should have. And one of the first one is discoverability and understanding. So you data users, we have to build this data as a product in a way that they can discover, know what it is, what it can do for them, understand it, how can I use it, so all of those good documentations, and we have really wonderful tools for that, right? So imagine computational notebooks, using computational notebooks for documenting the data products and be able to tell a data story with few samples of the data, few visualizations, all in one document. It's a wonderful way to kind of getting people to understand this data as a product. I put a lot of, I guess, a few other kind of attributes there to think about when you, on this slide, to think about what does it mean to delight the experience of the customer? What are those characteristics that we need to have? And we can get help from, you know, traditional product owners to help us think between, you know, at the intersection of product thinking and data. But this is all great, but how do we architecturally actually make this possible? We have come up with this concept called data product, which is a node on the mesh, which now provides data to the rest of the organization for a particular domain. I have an article, in fact, coming out, which goes into the blueprint of this architecture and what are the kind of the bits and other bits and pieces and affordances and capabilities of this now new quantum or unit of architecture we need to have. And I put some of them here, you know, in a simplest view of the world. This is a computational unit, as in it has code as well as data that on one hand consumes data from either an adjacent, you know, microservice operational system or an upstream data product. And on the other hand, it provides data in a polyglot format, because now when we talk about data, data can be used, the same data can be represented syntactically in many different ways, right? If you think about the customer and customer changes, you can think about it, okay, I'm just going to show this as flat events, right? That shows the change of customer over time. Your data scientists won't be very happy about that representation, and they probably want you to show the changes in some sort of a possibly, you know, kind of a micro batch format with columnar view, and they prefer kind of semi-structured JSON files of that columnar view. Give me all of the addresses for all of the customers we have, or give me all of the, you know, the profile of the customers that we have. So then you need to provide the same data syntactically, in same semantic, but syntactically across these polyglot output ports. And then you need to have a way to kind of control and tune the behavior of, or the policies that this data product need to apply around security, around access control. So this is a very high level view of the blueprint of your smallest unit of your architecture. But then the third pillar of the data mesh is really around abstracting away a lot of infrastructure complexities so that these autonomous, you know, architectural quantums, these data products can come to life, be owned, operated by independent teams. And I don't think this is a new story. This is an old age story around removing friction from delivery for now a new persona of developers. Now we have created this new persona of data product developers, right? Within the context of the domains that were building applications a minute ago, now they're responsible to build the data product. So what is this new infrastructure as a, you know, the self-serve capability look like? And this infrastructure maybe on the surface feels like, oh, I need to have, I don't know, Spark clusters, or I need to have some form of a pipeline orchestration or storage. And yes, you do need all of that, but there is a new level of abstraction and usability expected to be built so that you remove a lot of friction. You know, in a declarative way, a data product owner or data product developer can just say, you know, this is my data product, this is where the data comes from, this is the type of data I'm serving. Let me just focus on the transformation or the business logic, take all of the rest of the friction away from me. So that requires a very new experience for these folks. And finally, the fourth pillar of data mesh is really around bringing interoperability at scale. As soon as you distribute a system into multiple parts and new teams, you need to build something else in place so that these pieces can play well together. A data product, if it can't be merged or, you know, joined with another data product and it can't be aggregated together, we have really limited the use of this data. So then what are those standards that we need to bake in to the platform computationally in an automated way so that each data product can now talk to the other ones, right? You can think about IDs, the standardization of the IDs of entities that end up replicating in multiple data products. You can think about decisions around what constitutes the boundary of the data product. There are decisions that need to be made to really create a harmonious and interoperable ecosystem, and that can be done, in a federated fashion, as in people from different domains coming together and forming the nexus of this kind of federated group of data governance folks, and then bake all of that computationally into the platform, so you don't have to think about it or manually enforce it, right? So you just enable it. So in summary, data mesh is these 4 pillars that we talked about. And I think at this point in time is more important for us to agree upon the principles that hopefully addresses the problem of scale where we started this story, right? The moment of crisis that we couldn't scale. So hopefully by agreeing on this and implementing these principles, we can then have this world where data is really treated as assets. People are enabled to use data at scale, serve data at scale, and we remove the points of friction. All right, so let's bring these kind of 4 principles to life with a little example. So I've chosen the domain of health insurance for you. It's not the most exciting domain, but it's related to our health. So imagine that you are a health insurance provider and there is a domain called claims. There is a part of your business that deals with people calling in and making claims for, the expenses that they have incurred, and they want you to pay those expenses back and reimburse them. And you have provided a call center service, and part of your business is the call center receiving these requests, and there's a call center application that receives it. So to surface analytical data, so the data about all of the claims that have been made and are being made every day and whether they've been accepted or rejected, you have a call center system. We can think about now that domain, that subdomain, right? Call center claims subdomain. Within that claims domain, we'll have a data product called call center claims data product. And because this call center is a very old application, like many of the other ones, and the people who actually wrote the code for it are probably no longer with us, we have no choice but implementing the input port for that call center data product through, some sort of a technique like change data capture that would get data from the system. But it's the same people, same group of people, right? They're familiar with that system to a degree and part of that domain. They will receive the call center data as it happens, and then they would accumulate it and they will keep it for probably a very long period of time, and they will provide that data on the call center, let's say daily snapshots output port. So that becomes an output port, and I put a little bucket icon next to it indicating that this is perhaps a object storage that you can access to daily snapshots of the file. In the same domain, in the same business claims domain, you probably have a shiny new kind of microservices-based architecture for your online claims, people that go online on the internet and then submit their claims. And for that system, you may decide that the data product that now serves the view of the online claims that are being made over a long period of time. Again, we're talking about analytical data. So analytical data is not the current snapshots, it's all of the claims that have happened over an infinite amount of time, whatever infinite means for that particular domain. For that one, we would say that, okay, it's an online system, let's extend it. Let's add an event stream to it that they just put out with possibly very short retention, like, few days of the claims that are coming through. And the data product adjacent to it will be consuming those events, and we would keeping them and aggregating them over a course of period of longer, infinite kind of log of time, and now provide perhaps 2 modes of access. Remember, we talked about that polyglot output port because data consumers usually for the same semantic of the data, it's still a claim semantically, but they want a different syntax and different modes of access to it. We would provide 2 output ports. We'll provide an infinite event log, like all of the events that happen, and you can time traverse back and forth in time. And then we will provide an object storage of daily snapshots because that's best, suited for our, let's say, machine learning kind of access models. And for that domain, the claims domain, we would decide that, for the ease of use, we would have another data product, which is the aggregation of all of the claims. So people that just want to know about claims, they don't care about it's coming from an online system or coming from, a call center. We will have a data product now that its input ports consumes data from 2 output ports of the online, 1 output port of the call center, and it would aggregate that and would kind of synchronize that data and provide it as daily snapshots, again, as well as some form of an event-based, flattened event, time-based events that clearly for the call center ones is perhaps somewhat synthetic. So this is a data set of data products, that are perhaps slightly more tightly coupled or related, but they represent the claims domain. And let's continue with this conversation because, there are other domains in the organization, and there is a member domain that is capturing all of the changes that are happening to the members of this health insurance company. And the members data product has a daily snapshot member changes now. Members get registered, new members join, members leave the organizations, members change their status, they get married, they have children, they change their addresses. So all of that information over the course of time, an infinite, kind of scale of time are provided here. And because this insurance company cares about the health and the life of their members, they decided to create a new domain, members assistant domain. And the job of people working in this business unit is to pick up the phone and call the members whose health seem to be declining. How do they do their job? Well, we have built a data product that provides the list of members that they need to, maybe on a daily basis, a monthly or weekly basis, pick up the phone and call. And the way this member assistant data product works is that it consumes data from all of the claims information they see. They see which doctors you're visiting, which medications you're using, or what doctor appointments or tests or dentist appointments you're not going to because you're not making any claims. And they're seeing all of the changes that are happening in your life. So then they can build some machine learning, classification algorithms to put you in different cohorts. And if you happen to be in a cohort of you change your address, you seem to have lost touch with your, kind of doctor that you always went to, and you haven't been doing your annual test, we need to call you and perhaps introduce you to a new set of doctors that are now in your new hometown or new address available to you. So as you can see, this idea of the mesh really comes to life by connecting data from different places and start emerging kind of this intelligence by composition of the data. This is a very simple picture on the surface. Underneath it, the technology, if you recall that infrastructure layer, the infrastructure that needs to bring this to life, it requires a lot of innovation right now because we don't really have our technology off the shelf that give you this polyglot spatial view of the data over time or allow you to join easily across different domains. It is possible to do that with existing technology, but it requires a fair bit of custom coding and investment. But hopefully this example brings the idea of mesh to life for you. So this is where we were actually a year or two ago, where we came up with these principles. And since then, I think we've been trying to kind of pave this future vision and bring it to reality. And again, a lot of us, I guess, on this call are computer nerds and computer science backgrounds. And I love this quote by Alan Kay. The best way to predict the future is to create it. And that's what we've been doing. And that's what you will be doing as part of this journey to bring this new vision to life. The paradigm shift that really takes us from this centralized thinking to decentralized ownership of the data, from a monolithic architecture to a distributed architecture, truly a distributed architecture, not just at the file system level, but at the computational level, at the access level, decompose that. Let's change the language from this idea of pipeline as a first-class concept. I don't think pipelines have been very useful as a first-class architectural decomposition concern. And let's start breaking apart the architecture on the axis of domain, and an axis that represents the reality of our business. That's how we broke up the business. So why should we think about architecture very differently? Why should we think about our teams very differently? And really, instead of thinking about data as a byproduct that it's coming out of the exhaust of our operational system, think about data as the product. I want to touch on language because I think words matter. Fellini, the famous filmmaker, said that every time we learn a new language, we create a new vision of life. And maybe we're in a the inverse of that today. We have created a new vision of data landscape, the analytical data landscape. And with that, we need to create a new language. And on the left-hand side, I want the words that hopefully would disappear from a language because they're a little bit harmful, in bringing this new vision to life. Words like extracting data from somebody else's database that wasn't meant to be touched and extracted because it meant to be abstracted and hidden away behind operational APIs, right? Instead of that, let's think about serving that data intentionally through these kind of ports, through the output ports. Move away from this idea of hydrating the lake or creating this like centralized warehouse, and really ecosystem of well-played, integrated data products that can be composed into wonderful ways. This year, I think InfoQ recognized data mesh as on the innovation or adoption curve and the innovators space, which are technologies that early adopters are starting to adopt. And I think we're still talking about what is data mesh, and hopefully we start talking about how to do data mesh. So I'm very excited to share with you the second article coming out on data mesh, the blueprint that brings that to life, and hopefully we will have that by the time you're watching this video on Martin's website, Martin Fowler's website. Keep an eye on that. And we will have a lot of more sessions to talk about how to do data mesh right. And hopefully with this kind of, this new paradigm, we would bring that operational and analytical planes closer to each other and align them around domain thinking, around domain ownership. And it's really one continuous feedback cycle, right? We get data from operational systems, create that analytical view that contributes to intelligence and intelligently augmented APIs that then feed the operational systems and so on. So this was the story of the data mesh. Hope you find it useful. I'm excited to be in person with you in not so long from now and answer any questions that you have. Thank you.